Thank you, folks. Thanks for coming out. I know it's been a long 2 days. So I'm very excited to present here with Ruben. Our basic agenda today is, Ruben's going to talk a little bit about Vision Banco. So Vision Banco is actually in their 4th generation of deploying an artificial intelligence solution. And it's evolved from various tools. So it's a very interesting story of how they've sort of progressed their solution. And so he's going to talk about their journey, a little bit about their AI architecture, and a little bit about lessons learned and what they're sort of looking forward to in the future. So along those lines, here's our Twitter handles. If you want to tweet along the lines, we welcome you to do that. And hopefully there'll be some time at the end to sort of ask questions. So with that, let me pass it over to Ruben.
Hi. Let me introduce myself. I'm Ruben Diaz. I'm a data scientist from Vision Banco from Paraguay, South America. My country, Paraguay, is in South America, in the center of South America, with a population of about 7 million people. We speak Spanish and a native language called Guarani. Myself, the tools I use are SPSS, R, Python, H2O, Driverless AI, DB2, IBM DB2 database, and IBM Cognos. Vision Banco is a Paraguayan bank member of Global Alliance for Banking on Values. It's a top 10 bank in my country. The Vision Banco got the largest numbers of agencies and is the major employer in the Paraguayan financial system. Our customers, because it's a bank for microfinance and small business, the bank is very inclusive, and we reach 1/3 of the population of Paraguay in economic active. So we will talk about how we get here. We started to do predictive analytics almost 5 years ago, and to use H2O, the core version, the open source version, 3 years ago, and recently we are using Driverless AI in IBM 922, AC922 hardware with NVIDIA GPUs. One of the use cases we were able to double the propensity to buy of credit card offers. We start the typical use case for financial institution is credit scoring. So our first model we developed with an external consult using IBM SPSS, and we deployed that model as a stored procedure on DB2 from 4i. That hardware is more known as AS400. The state-of-the-art algorithms got better accuracy than logistic regression. It's a good algo, but random forest, GBN, and others got better accuracy. but they are not easy to deploy. So we we export that models to the standard PMML format and implement this model with as a web services using the tool OpenScoring.io. When we find H2O, the open source version, almost 3 years ago, H2O surprised us for the speed to train models. Using R and training a random forest could take hours. But with H2O, that just take minutes. So you could do more models in the iteration of a data science process. And then we adopt H2O open source, and we change the deployment from PML format to H2O pollos and mojos, a particular way of export models for deployment that H2O has. Recently, actually, our new developments with machine learning are using with driverless AI on a IBM Power System AC922 server with NVIDIA Tesla V100 GPUs. Each step improved the accuracy and the speed of model building and deploying. Our use cases are typical for risk, credit scoring, the default prediction, fraud detection. For business, propensity to buy, customer churn prediction, customer segmentation, recommendation engines. How do we start to using driverless AI? Circa November 2017, I joined as a beta tester for driverless AI. As a proof of concept, I joined Analytics Visa contest data science hackathon churn prediction. Surprisingly, I got the A place. And people from 1 to 7, some one of them were Kaggle masters. So I'm okay. It's an awesome result. There's the link to the blog I wrote about it. And this proof of concept was with this proof of concept, I combined business people to buy driverless AI and then the hardware to run. Hello.
So many of you might have been hearing about driverless AI, but if you haven't so far, just a quick introduction. So driverless AI is really focused around automating the machine learning process. When you look at automating the machine learning process, there's a whole architecture around it, and driverless AI is focused on the area here in the gray. So the data prep sort of happens outside. You got to get the data prepared. Driverless AI is really focused around supervised learning. So there's some kind of example that it's trying to follow. The data is sort of labeled, and it's going to learn from that. So driverless AI kind of has 4 key capabilities. One around data quality, so to allow you to do some data visualization, some data checking, to see if the the data that's being prepared is at a good state. And the other thing is that it's focused around this automated feature building. So in that, it's like there's feature engineering, there's picking which model to use, doing various iterations, getting a lead model, right? And at the end, kind of facilitating building a pipeline. So if we look at what that looks like, as Ruben mentioned, he has various data sources. So in his case, he's using many SQL data sources. There's a data set where we have data that's labeled in our target. And we start with sort of this auto visualization to kind of look for outliers, looking for correlation between data sets, see if the data is prepared well, right? And then you sort of come into this whole automatic model optimization, right? Where you have feature engineering, algorithm selection, and model tuning, right? And it goes through an iterative process to kind of select the best model. Once the best model is sort of chosen, at that point, we automatically create a automatic scoring pipeline. That automatic scoring pipeline includes the feature engineering and also the model itself. And at the same time, you can create a series of model interpretability reports. Some of that's reports and some of them are surrogate models to understand the model that was built, right? So now Lucy's going to talk a little bit about the platform that it's running on top of.
Thank you, Rafael. Hello, everybody. My name is Luis. Well, I represent IBM, and we are very happy. Perhaps if we didn't introduce this before in other charts and presentations, H2O Driverless AI is part of our Power AI portfolio. As you notice, we have all these pieces in our Power AI portfolio. We have Power AI Base, we have Power AI Enterprise. I'm going to be more than happy to talk to you offline about our different offerings. But in the top, we have the two tools that we said that are for data scientists and not data scientists. One of them is called Power AI Vision, and you just saw this morning one demonstration from Paul in the main stage. And the other piece that we have in our portfolio that complements very well is H2O Driverless AI. So it's part of our offering, as I said, and every time that we talk about automatic machine learning, driverless AI is on there. And what is really important is that what happened after the deployment. So we need to talk about that, and this is the infrastructure. And we need to have a strong infrastructure where we're going to run the models. And we have the best server that exists in the market, that is the AC922. And why is the best hardware that exists? Is because it's the only one that has the capability to connect the GPUs and the CPUs with the NVLink, which is the fastest interconnection that exists in the market, that was co-designed by NVIDIA and IBM. So this server has this NVLink. It can have the same access to memory with the NVLink technology, so we can use large model support as well. And well, it has PCI Gen 4. It's the only server that exists in the market with PCI Gen 4. So again, if you want to know more about these offerings and about this great technology of the servers, please talk to me after the talk. Thank you.
So thanks, Luis. So, we started, Ruben started this session talking about his journey, right? And at the end, it's really, we're seeing customers, what they want to do is build an AI solution, which is what you're sort of seeing at the top right. And in order to build an AI solution, you need a whole sort of infrastructure to kind of make that happen, right? So you need data clearly, you need to do some data preparation, you're actually looking at building models themselves, because they run on infrastructure. There's a model phase, and at some point you're going to look at deploying that. And at the end, it's going to lead you to sort of build these AI and potentially BI solutions. As you look at this AI solution from driverless, not only is it part of the modeling phase, but it's also part of the deployment phase, right? Because you're going to deploy those models, whether it's in batch and real time, to actually score data. So with that, we'll kind of look at Vision Banco's architecture and how they're using driverless AI within that.
Okay. You can see that we got a lot of data source to the machine learning. In data preparation, we use a lot of tools: SQL, R, Python, Java, Ventajo data integration for ATL. Actually, we're doing more the modeling with driverless AI. we use RStudio and Jupyter Notebooks too. I want to, of course, with the we got on-prem cloud, on-premise cloud with Power 9 and using Kubernetes, Docker, and other tools. I want to talk about how we do the real-time scoring. We do real-time scoring deploying the models of the open source version or the module pipeline of the driverless AI. The workflow of the bank captures features. With these features called the web service based on the modules of H2O, and with the result of this course, the system take an action. By the way, I share a tool at GitHub that helps to deploy modules from driverless AI and open source version like a web service. You can get with the QR.
Yeah, so if, the nice thing is that he's sort of one of the early adopters with driverless AI, and he's kind of taken this and built these models and put them into production, and he's created a tool to make it easier to deploy those into his environment. So his GitHub is available if you want to contribute or sort of leverage that in open source. The other thing that's sort of really important in the Vision Banco scenario is being able to do machine learning interpretability, right? And not only is there governance for banking within the US, but clearly there's governance bodies around the world and also in Paraguay. And so they use driverless AI not only to build the models and do the scoring, but also leverage the machine learning interpretability. So in this case, they build the model and they want to be able to, in this case, they're looking at models around loans. They try to make a decision on whether to accept a loan or not. They start with some initial features, whether it's around payment history, location, profession, and et cetera. And once the model is built, they're trying to understand this black box and what are the main drivers with that. So as they explore the model, right, they're really looking at, they're trying to understand that model, and so they'll use techniques like reasons codes, Lime, and Shapley values to understand it. And so that explanation that they're looking for is, they're trying to discover things like, the people who should we accept loans are people who make regular payments, people who have steady income, and people who have stable jobs. And so this is the insight they're sort of driving to get, and they're getting from the MLI sort of reports. And at the end, what they want to do is accept a loan and provide more good loans to more people. So with that, back to Ruben around lessons learned.
What we learned? Automation of a data science process reduce time and cost less money. So time is money. So you can do more with the same time. So it's possible to deliver more value to business, develop more use case in the same time period, and focus the data science effort in the use case instead of development tasks. It's very important the interpretation of machine learning to explain decisions to business people and to customers. Looking to the future, when future use case will be money laundering, prevention, time series forecasting. Driverless AI is prepared to do that. natural language processing, also driverless AI helps with that. Chatbot, voice, sound, image, and video processing. Muchas gracias. Thanks. And do you got questions?
We have time for a few questions if you want to have questions.
Thank you, Ruben,
Yeah.
Luis, and Rafael. Thank you so much for sharing us your use case. Thank you so much.